Let's talk about the criteria, AI criteria. What criteria should AI meet in order to perform well with the different problems? AI should be ethical and compliant with laws and regulations. Please welcome our next speaker, Professor at Ivannikov Institute for System Programming of the Russian Academy of Sciences, Harutyun Avetisyan. He's going to talk about trusted AI, challenges and opportunities. Good afternoon, everyone. Today I will try to give you my take on trusted AI, what that is, and what are its challenges and opportunities. I'd like to start with a short story. Which one of you knows that on December 4th we will be celebrating the 70th anniversary of IT in Russia and post-Soviet countries? 70 years ago, on December 4th, the first patent application was submitted, and now we are receiving a lot of celebratory letters and congratulations. What Sberbank is doing is a great endeavor, great enterprise, very successful one. Yandex and other companies and our institute, all these things have emerged because we started back in 1968. We developed this machine that is on a par with one of the best machines that is now studying in London. All the things I'm going to talk about today is based in one way or another on our experience, my experience, the experience of our team. These are specific results that I would like to share with you. But first, it's been a decade or even more that we are in a world where we are ordering our technology. This is socially driven development. BSM-6 is from military and industrial complex. Other machines were ordered by the financial industry, and now it's all kinds of businesses and different economic sectors. Open software. Lots of software that is now available and that was made possible not because there is a bunch of enthusiasts working on it. There are governments that make an impact. Linux appeared because 3 operating systems in the US were developing simultaneously. And that energy had to go somewhere, that creativity had to go somewhere. Instead of creating new technology, those people were competing with each other. It's like in the automobile industry, instead of creating cars, they would be building roads. Fortunately, that's not the case, and this is one of the reasons behind the rapid growth of everything around us. And commodity hardware, another thing. I was personally involved in development of supercomputers and software for supercomputers, and I can say that at the end of the 90s and beginning of the 2000s, gradually we saw a significant shift. In the top 500, you would not find a supercomputer that would not be built on a specialized hardware. Very few exceptions to this. This means that we live in a world where there is this GitHub phenomenon with hundreds of millions of programmers, billions of lines of code. The complexity of these systems is enormous. It is not only due to the size of it, but it's also the sophistication of the systems. This is the world where we need to ensure the quality of software, its efficiency, productivity, and trust in a broad sense of the word. This is what we have been doing for a long time. We had our first contract on trusted development, safe development with a Canadian networks company. This is where we made a lot of progress. I know this firsthand, and I wanted to give you this excursion to show that with the emergence of AI, we got new challenges. And this trend, I think, will persist. It's important to remember this. 1999 common criteria by the US government was adopted, and very soon anyone who did not have the relevant technology and were unable to ensure the quality of their solutions at the necessary level, they lost access to the market. Nordo signed the contract with us for that reason. That was the vision of Microsoft at that point, with Nista and other companies, so it was declared, and then technologically it was supported by other companies, by businesses, and startups appeared. Coverity from Stanford, for example, they were compiling very well. I know them. It was declared that from design to support software had to go a certain path. There had to be checks and tests. Antiviral perimeter fencing was no longer enough. As a result, this standards CI/CD pipeline was created, and it is now viewed as a mandatory tool in the security arsenals, statistics analysis, phasing, a deeper analysis, and a compiler, especially if it's a mission-critical system. Of course, there are no universal pipelines, because if you take embedded systems, you would need to configure it in a certain way, and even such standards as the Mistress standard were developed. This is a broad topic. I don't want to go into details there, but still, this is a well-known technology at this point. Over the roughly 15, 20 years since that was first developed, lots of resources were allocated for this development. The best universities in the world, the most leading companies, major companies were involved. We were involved as well, and a number of technology was developed. We are proud to say that we are probably the only center, other than the US centers, that have the full stack of technology, from the secure compiler all the way to dynamic analysis. Our products are competing on the global scale. For example, our flagship SVACE statistic analysis tool, implemented at Kaspersky, Postgres Professional, and Samsung and many other companies, also implemented at international corporations. We have to remember that in this world, even in regular software, and I will gradually transition to AI. Anyway, in this world, if you're not moving forward, in other words, if it's just a product that you're trying to maintain at a standard level, you will not be able to support that for a long time, maximum 1 or 2 years. In statistic analysis, 7 to 10 years ago, dynamics was not used that broadly, and now symbolic execution is just this standard tool, standard part of this technology, which means you need to satisfy the needs not just in detecting deficiencies and vulnerabilities, you also need to satisfy non-functional requirements. For example, there have to be certain RAM restrictions, and other parameters need to be configured in a very specific manner. So this is a very sophisticated technology, available not available to everyone, only to certain countries in the world. In systemic programming, we are highly competitive, and our technology has been developing very rapidly. The next steps in developing the traditional technology that we have been implementing for a number of years now, and we will continue with their development, is all associated with the buzzword of artificial intelligence. We're living in the world of buzzwords. What is AI? What is trusted AI? Everyone has an opinion on it. If we try to formalize the definition, we would probably fail, and people in the audience perhaps know this, perhaps would agree. But as we are here now discussing this technology, I would assume that we are roughly on the same page about it. So let's talk about this phenomenon, which has become, over the past 10 years, it has become one of the key technologies, AI. The question is, what are the new challenges? What do we do about it? For us, it was clear that, and I wrote a paper on it, by the way, a small document. We knew that this was a big thing that we needed to venture into in a couple of years from then. Now, those who did not have this trusted technology, they would not be competitive, they would not be able to compete on a global scale. This is due to a number of
критически важными
critical
особенностями искусственного интеллекта, которые, кстати говоря, в 1956 году или
properties
1954
of
году как
AI.
раз было озвучено,
In
что есть такое направление.
1954, this
Большие данные
in 1956 rather,
вначале по
this
изображениям
notion
это было
appeared. At first,
огромные
it was
ресурсы
images,
компьютерные.
lots of
Многие
computing
результаты, которые я,
power,
вот, будучи студентом, занимался
and lots of
распознаванием образов,
results
я
that were
помню, и
achieved. I
те
was
результаты,
working as a
конечно,
student in image
не очень
recognition,
хорошие
and the
результаты,
results that
но
we
мы видим, что
got,
в мире на самом деле
we
не
could not
смог
deliver.
достичь там на больших
No one in the
объемах
world was not able to
различных
deliver. We
данных.
were
И
using
с
big
помощью
arrays of labeled
суперкомпьютерных
data, and thanks to
вычислений
supercomputer
было получено
calculations, we
результат
were able
почти
to
на 100% в
deliver a
распознавании, классификации
100%
каких-то
almost
объектов. И это
accuracy in
произведено за
classification.
последние 10 лет. Сейчас
That
мы входим
happened
уже в эпоху
in the last decade.
генеративного искусственного
We
интеллекта.
are
Уже дальше
now
понятно, что в
living
ближайшее
in
время
the
будут прорывы.
generative
И
AI era, so
все это будет
we
внедряться так
understand
или иначе во
full
все
well that there
сферы
are going to be
жизнедеятельности, и остановить это
major
невозможно.
breakthroughs.
Потому
You
что
cannot
продуктивность труда
stop this
растет так
development because
драматически, что
the labor productivity
пытаться
grows
не
so
внедрять не
dramatically
получится.
that you won't
Я
be able
мое прошлое все-таки
avoiding
и был даже комсомольцем,
the
я помню,
implementation. You know,
Классовский говорил, что 300%
I
прибыли
saw
макротруд продаст. Капиталист. Так вот,
the communism era. I even was in the Komsomol movement, and they were saying that
есть какие-то проблемы
capitalists will sell their mothers to increase the profits 300 by 300%. And we need to understand what are the problems, what to do with the current developments that we had in the last 20-25 years.
Потому что во всех сферах цифровизация
How applicable is
связана
it?
с искусственным интеллектом. Сегодня даже
Because the digitization is related to AI.
они уже внутри
And now all the cameras that we have, they have integrated AI solutions so that it improves the quality of the pictures that you take with your smartphone. Now this is the tech cloud. That's the data landscape today. Also ML and AI. OpenCyrus, that was the project on clouds in 2010, and I represented Russia. It gathered the scientific community, including Stanford professors and all the rest. And one of the initiators of this project announced publicly that they are opening Hadoop stack of technologies. They went about it in the proper way. They created a fund. Unlike the Solarius, well, you remember the story, I guess. But anyway, they gave it fully to the community, and in just several years, there was a disruptive growth in these technologies. We saw DataSpar, Ignite, and all the other things. In 10-15 years, we saw disruptive growth, and many of these technologies are now mature. They are now actually used in and applied in the manufacturing, for example. They're not just confined to R&D labs, although some of them are still. Anyway, what world are we living today? We know the problems related to AI, and these are the practical problems. We know the situation when a bot was hacked, when chatbots started to harass people in social media. Confidential data can be taken from data arrays, and if you put some small changes in the stop sign that we won't even notice, a car will not see that, and it will think that there's no stop sign, and it will go on the red traffic light. These are the stories that we know. Gender inequality, that was another example of AI bias. In October this year, there was a book produced, a book about mushrooms. Well, Russians love to gather mushrooms, and those who know anything about mushrooms, they understand that if you use this book, actually you won't end up in a very good place. This
насколько важно, чтобы мы как-то вот с этим совсем имели дело.
AI written books
Мы должны быть
are obviously no good and even dangerous. So we have to be tech savvy on one hand, we have to know the technologies, on the other hand, we have to build the processes to make sure that people participate in mission critical processes. But how do we ensure that participation? How do we organize it? If you take ML in this large cloud of tags that is mission critical point, the critical point really, and vulnerable point, it is surrounded by
не обеспечив
the environment that should be safe. You have to implement end-to-end approach here. Everything should be secure and safe, because otherwise we will have a system that will behave in a ways unexpected. That's the mild way to put it, because, you know, that's a bad thing to have. Because if you're driving a car that is controlled by AI, you expect the car to behave adequately to the situation and stop when it needs to stop, obviously. But if we go back to ML, these are the things that are now kind of considered similar, AI and ML. The nature of AI is as follows. The vulnerabilities of the model that we use are uploaded through the data, through the dirty data, poison data, so to speak. We are using the models pre-trained by someone. We retrain them, but these vulnerabilities can go through open frameworks like PyTorch. We have our own framework in Russia, by the way, but anyway, it's not important. They can get into the model from this framework, through this framework, and then the model can be retrained in a cunning way so that it is vulnerable. Vulnerability means like the traffic analysis. Traffic will go through some system and you won't even notice that. It's not even important that it is a text. Might be some story, whatever. The most important thing that I want to say, when you hear the word poisoning, you think, well, someone poisoned it on purpose. In software, in like traditional software, it is put in protocols, and students are told that if this error, if this vulnerability was made because of some of the problem implemented in the code, it's likely to be an error. The same with poison data. If you don't know how to work with data, your data are wrong. And that's it. And the criminal can use that and attack your model. Now, that means that with all this, like all our toolset can be used for frameworks only that are within this secure development pipeline. As for the ready-made models and data, well, for them we need to create a new technology and scientific base to make sure that these are trusted technologies. Now, what do I mean by the word trusted? We have this trust, like we trust someone. That's a totally different thing here. Technology is not about trusting in the way humans trust each other. It's about if we can check the procedure. If there is a procedure, if you take a regulation, you can say there is also kind of trust, for example, in when there is a trust when you have a power of attorney, for example. But anyway, there are 6 levels of trust in a technology stack. If you look at that, there is no regulation in AI. If you look around the world, you will see that there is no real regulation that will regulate AI. Understanding that problem, several years ago, Sberbank and a number of other companies and the Alliance of AI developed a special document that we also signed. This is a code of ethics for AI. It is now signed by many other companies and even countries, because if you cannot check something from a technological point of view, you have to reference yourself against the fact that the solution that you develop should be developed in line with the requirements that are set right now. The world has various subcommittees and organizations that do the regulatory work. In 2020, Europeans said that the AI will be divided in two parts. One part will be a regulatory part, the regulated part, another one will be unregulated part. But in 2 years, in May, we actually organized a conference on trusted AI in our new Moscow State University facility, and the Europeans said that actually the part that is not regulated, the AI development part that is not regulated, is going to be banned for the use. We had a discussion with the businesses community as well, and the businesses said that 18% of developers will leave Europe because this is a no-go rule. That means that this is a area that is dynamically changing, because the society as well as the scientific community do not quite understand whether we should regulate or whether we should not regulate the AI. And that is explained by the fact that we do not have technologies, the ready-made technologies that we can use as best practices, which actually happened with the traditional software. And the fact that security is one of the key areas, and trust is something wider than just security. Based on that, several months ago in Hiroshima, around 27 countries gathered, I think, and there was a document signed by Biden as well. And in September, Biden's administration and the top five American tech giants signed a document that any generative AI must have watermarks, so that consumers understand whether it was generated by a generative AI or not. Why? Because there are no technologists that would say whether it's a fake or not. I mean, you shouldn't force the AI developers to follow all that rules, because, well, Kandinsky generated something, and, well, it's great. We use it. It's fantastic. But there is no way to understand whether it was generated by AI or not. But the US administration decided to sign and adopt that document. There's quite a lot of research papers from R&D teams and universities looking at that issue. And we have been looking at that issue for a long time. We are using these technologies for the printers, for the monitors, and we're going to kind of use this technology in AI, like the watermark technology, and hopefully with Sberbank and Yandex we're going to drive this technology. But anyway, we decided to follow the regulation. Those who provide AI-generated content without marking it with a watermark will be outside of the law space. And this is something that happened in the last several months. I'm an expert in this field, and like even 5 years ago, it was obvious for me and my team. Actually, 20 years ago, the same happened with the traditional software, and this is why I talked about this story. As part of our efforts of the Trusted AI Institute, Trusted AI Centers, and we won the competition, by the way, among the Russian universities. We are responsible for trust in AI. We took TensorFlow and PyTorch, and any other framework can be also analyzed for vulnerabilities. PyTorch and TensorFlow had a lot of critical security vulnerabilities. If there are any questions, you can ask them, and we invite you to our institute so you can look at that, at our work. Now, this is a very controversial example. When you use a library, and this is where you can load the untrusted models, and a random code can be executed on your computer there. Let's make an analyzer, static analyzer, and find this thing, and there will be no problem like that. Well, that doesn't work. We're professionals here. We're working on that issue, obviously, and the analysis should be more deep and dynamic. Other approaches should be used, and we're going to resolve that problem. But anyway, this is something that we see on the surface, really, a problem that is obvious, although we are using this infrastructure quite actively. So a model can be loaded to your system, and it can just run a random code. It really shows us what world we live in today, and that the frameworks that we're using right now can have can cause security problems. Now, vulnerability of ML frameworks and data poisoning. Injecting backdoors. Now, all of these pictures are marked as a bird, but we can see that there are no birds there. By implementing a trigger there in the input, we give some part of the data that are prepared like that. There's no serious math behind that, but I think like 10% would be enough. Like several percent of this data, a couple of percent of this data will be okay to use this trigger to execute an attack. On the lower hand side, it's more complicated. You take an image from another class, like this fish, and you select it so that the output of the layer before the last layer would be the same as the target one. And this is how the classifier will be hacked. So those who give you this poison data, or if they understand that the data that you have in your selection are poisoned, it is a vulnerability that can be exploited by the hackers. And these are our results of our work and the publications. There's quite a lot of publications that we have to protect you from that. Now you have a test base, you run your neural network on the test base, you select the neurons that are used, that can be exploited, and these parts are removed. Usually in large NNs that works. I mean, you have to experiment, but this is how it works. You just cut out this, bad thing from your neural network. And you can also have a data set that you use for training. You run it through AI, and you use AI to understand what parts of the image made the machine to make a decision, and you understand that if it is a sample, a pattern, that's a trigger. So you can fill in this part of the image, and this is how you resolve the problem. Now, these are there should be some solutions that would resolve this problem at a touch of a button. We're trying to work on that. But the thing is that it is all related to the type of the data, to many other things. And for now, there are no ready-made technologies, that I talked about before. This is a state-of-the-art R&D thing, really. But obviously, this is just one problem out of the scope of problems. And the adversarial attacks. Several months ago, I visited China and saw panda. I really like pandas. This is the image I like. And this panda became a gibbon after some noise was added. The same with the dog here. There was some picture added, and it's not a dog anymore. Alexander Gasnikov made a presentation here, and some other prominent researchers, mathematicians.
I also work in the mathematical department, but I'm not a mathematician. I'm an IT guy. So we have this mathematical institute, Stiklov Mathematical Institute. Alexander Beznosikov is one of the great people working at the university, and I'm proud of it because it's at this cross junction between different disciplines. It's there that you can make great achievements. Even though you have 100 billion parameters, when you have that, the curse of this enormous size, the enormous dimensions, you cannot do anything without good math. This is our colleague Kostya Archipenko in that picture. We have generated an image where we bought a T-shirt online. You put on this T-shirt, and computer vision stops working. It breaks down. It stops recognizing you. Then you additionally train the model. We have run the tests successfully, and then it starts recognizing you again. We were told that, well, it's a white box, everything is available, and you're able to peek inside and figure out what's happening, and so it must have been easy for you. But if you look at the research literature on this topic, this is also applicable to the black box, when you do not know what is inside this computer vision, what is the system behind it, but you can transfer it from your previous experience, from your previous experiment. It's a bit more difficult, but this is something that can be done as well. I have my computer vision system that we were doing from scratch. I think it would be silly to try to close this research. I think open source research would be the optimal way. Given the shortage of time, I'm going to skip through these slides, several slides about the institute, the things that we're doing. The fact that we're doing them is great, but in conclusion, I want to talk about the vision, where we should be, what we should be focusing on. Because we can come up with great technological solutions, but we cannot cover the entire front. Open source AI solutions is a great thing. We should keep our contacts with the global community. What can we do in Russia, though, in the environment that we have built for ourselves? Any company anywhere in the world, even in the US, uses the billions lines of code, open source, to develop their products. According to local regulations, it has to comply with the certain number of requirements for its trust. Basically, they're doing it in parallel. For example, 40 operating systems, 3 major ones in parallel, developing their own security solutions. But they are not selling it in the market, they are selling the functionality. Why not combine it under the umbrella of the research center, non-commercial center, and companies and users would be taking the key components from them. The quality would be consistently good, constant updates that would be in this repository, and this way all the problems that we are facing at the moment, not even related to the status quo environment, it's dynamic. Our business this way would get technological independence and quality products. We launched this project 2 years ago. We first used the Linux core, 15 projects at this point, including PyTorch. project. Over the past 18 months, we had more than 250 patches to the Linux Foundation. So we are generating a flow of patches only strictly related to security. The results are available to anyone in the world. They are openly available. The main thing is that 60 programmers from different companies that are competing in the market, Astra, Sber, Yandex, Basalt, Kaspersky, they're all in the market competing, but in this case they are doing it jointly with us. We, being a non-commercial state-owned organization, at an equal distance from business and state, we could support this trajectory. This model can be extended to AI and other complicated, complex technology, but with AI, we have to do it together. Unless we're able to collaborate with such collaboration models as this one, we will not be able to achieve technological independence, even though separate companies may be successful. We've had colleagues from Malaysia and other countries, and I've been listening to their presentations, and I thought that only together we can do that. I was at a BRICS conference last year. I was also promoting this idea that it should be elevated to the international level. There was a strategic session on September 26th, where it was announced directly that we must create a repository of trusted solutions in AI at the international level. I think all of that taken together, this could ignite if we have the business will. On December 4th, you are very welcome at our conference, at our institute. There will be a plenary session with several ministries represented. It will be networking and parallel tracks, including tracks on AI. It's completely free of charge. The Russian Academy of Sciences is organizing it. You just need to sign up. More than 2,000 seats in the audience, so enough for everyone. The more people will come, the better. We would like to communicate. Without this communication, without the collaborative goal setting, we will not be able to face the challenges. The challenges are global. We cannot respond to them simply with local mechanisms. That's how it works. I think this concludes my presentation. I'm happy to take your questions. Thank you. Thank you very much for your presentation. Lots of questions. The topic of security is a big concern for everyone. We do have questions from the audience, but I'd like to ask my own question first, if I may. We've learned the reason for firing Sam Altman from the CEO position at OpenAI today. Reuters agency released the news. There was this breakthrough research that may be a threat to the entire humanity. What do you think about it? I don't know what mass media are writing about. I am a science guy. In my opinion, I know that there is this optimistic scenario, this optimistic vision about getting an AGI in the very near future. I don't think this is possible in the next dozens of years. Google published an article about it very recently, and I have been saying the same thing for many years now. You can look it up online. What I'm referring to is a narrow AI, which is basically an IT technology, a complex one. Speaking of the legal aspect of it, you can study the international discourse. No one is saying that we would give subjective agency to it. No such thing. This is just a complex IT technology. I think we need to delineate these things. If we do get AGI, this is what futurologists should be concerned with. Researchers keep working on it and receiving funding with great enthusiasm, but those are two separate worlds. From the marketing and promotional point of view, you can write anything, but it's going to be an AI that is very much advanced, but it's not general purpose AI. Okay, thank you. A couple of questions from the audience, more domain specific but less clear to me. What are the prospects of AI training in domains where trust is key if data sets cannot be filtered and validated with 100% certainty? Great question, but a more simple task is with regular software. When you are passing all these levels in Russia and abroad, no one's going to sign their name under the statement that we guarantee there are no errors in it. Formal verification can be a possible path. If there's more than 10,000 lines of code, you can't do anything, but with the 10,000 code, you need 100,000 codes of verification. There's a whole thing. I can speak for hours about it. It's not that we guarantee there's no errors in it. It's just that at the technological level we're at right now, we have explored all our opportunities. We have applied all our capabilities. At level 6 of the stack, you just need to provide the source. At 4th level, you need to produce a statistic analysis. At the 1st level, you need to verify certain parts, which is mandatory. It's too early to say. At the latest conference, the regulator said that we need 2 to 3 years to catch up with the technological base for serious regulations. The first draft has been prepared this year. It will be similar to what the US and the EU have. Technologically, we are pretty much on the same playing field. We guarantee that there are no errors in our systems. Well, this is the same statement as the statement, I'm never going to fall ill. You can take care of your health, but this is going to mitigate some risks, of course, but there is no 100% guarantee. Same goes for software. In principle, especially with what we have now, the technology is so complex that it poses even greater challenges. Another very complicated question. Does the Russian Academy of Sciences and your institute have any plans to develop PyTorch frameworks? Yes, PyTorch and TensorFlow. Right. Those frameworks based on SAFC. I've recently got this call from my friends asking, can you develop an operating system? I said, no. What do you mean? Well, we can develop it, but it would be impossible to maintain it for a long time and support it for a long time. Why have I been talking about the open source code? It's not like you can or cannot solve a problem today. Maybe you can, but can you maintain the development capabilities for many years to come? New ASICs, we have a Russian company that does neural matrices. This is all changing all around us. You need enormous amounts of resources. PyTorch and TensorFlow requires lots and lots of innovation power, innovation capacities every day. Just sit down and think about it. Not necessarily these two. Compiler GC, for example, that was the main compiler of Linux. As soon as LLVM emerged, we had 5 official reviewers on our team, and they said, we love this project, but you really need to focus on it. When we started working on it, we got a lot of solutions. But developing something from scratch is counterproductive. Instead of working on real tasks and developing technological independence, you would be allocating most of your resources working on the infrastructure that could be worked out collaboratively. Linux is a great example. How much are our companies investing in it? 0.1%? Or what? 300 to 400 million lines of code. We have this product because of collaborative economy. We're living in this world where collaborative economy is behind everything. We are not in any dependence. At our center of system programming, we are going to be synchronizing the solutions that exist elsewhere in the world and providing them to business, and business would be applying it to their practical needs. Let's discuss it, let's collaborate. That's why we're participating in these conferences, in order to communicate rather than working in silos. Thank you. I agree that this conference is organized to discuss such serious topics in order to work out interesting solutions and creating teams dedicated to it. Yesterday, the AIJ contest award ceremony showed how interested young people are in it, in this teamwork. What is the biggest danger of AI for modern society? The biggest danger, I think, is that we have to adopt it. We can't do without it anymore. Meanwhile, society does not always understand its complexity. Public polls say that 80% of people trust AI, meaning everything is good. But it's not just an issue of trust. We are drinking a bottle of water not because we trust it, but sometimes it's because of the marketing approach and market analysts that made us trust it. I think this is what we need to focus on. This thoughtless application of technology, including AI, and digitization is everywhere. You can't do without it. Will be a danger, I think. 10 years ago, Audi, I think, announced that software failures happen more often than with hardware. And now that we have AI driving it, what if there is vulnerability and your car drives into a lamppost? Something needs to be done about it. Without the scientific and research foundation, without a dialogue about it, which model are we trying to copy? If you don't know your destination, you probably won't get it. Thank you very much. Thank you for your answers. This applause is for you.